Discuss about embedded systems. So our topic is about embedded system design, and in today's class we are going to learn about introduction to embedded system. So what is an embedded system? An embedded system is said to be an electronic or electromechanical device which is designed for a specific function. Okay, and it is a combination of hardware and the software. So here the main purpose of using an embedded system is to design a specific application or in order to develop a specific domain. Okay, so every embedded system will be an unique. We can consider examples like washing machine, digital camera, etc., etc. Okay, so here we are saying that every embedded system is an unique because it is designed to perform a specific function, or else I can say it as an in order to perform a specific application. Differences. So as we are going to learn about an embedded system, first we will be seeing the differences between a general purpose operating system and as an embedded system. Here the general purpose operating system can also be said to be a general purpose computer. Okay. So what is a general purpose operating system? What is an embedded operating system? As we already said that in definition, embedded system is designed for a specific function, but whereas in a general purpose operating system where we can be used for multiple applications. In order to increase the performance of our multiple applications, we will be going for a general purpose operating system. So what is a general purpose operating system? First, a system which is a combination of generic hardware and a general purpose operating system for executing a variety of applications. So with the help of general purpose operating system, we will be using a generic hardware and the general purpose operating system in order to develop a variety of applications. Whereas we are coming to an embedded system is designed for a specific application with the help of embedded operating system. Okay. Next, here already mentioned that in general purpose operating system we will be using a general purpose OS, whereas in embedded operating system, depending upon the performance of the application or the system, we will be using an operating system or we may not be using an operating system. And the third one is in general purpose operating system, here the key deciding factor is the performance. Performance is the key deciding factor. Whereas in embedded operating system, it is an application specific requirements. Depending upon the application, we are going to develop a certain functionality here. Whereas, okay, next, whereas we are coming to a general purpose operating system, response requirements are not time critical. Okay, here where we are coming to an embedded system, it may be time critical in some places, it may not be time critical in some cases. And here applications can be alterable in the case of embedded general purpose operating system, here cannot be alterable. Okay. And next one is a need to be deterministic in execution behavior. So what is the need to be deterministic in execution behavior? So whenever we are applying an input, okay, we are expecting an output related to an input which is said to be deterministic. Okay. So here in general purpose operating system, so whenever we are developing an applications or we are performing any function, so we know that for this input we will be getting a certain desired output. That is said to be deterministic. But whereas in the case of here in the case of GPOS, in some cases it might not be deterministic. But whereas in the case of embedded operating system, it should be deterministic. Okay, here are some of the applications of an embedded system. So the applications are the consumer electronics. So here in consumer electronics, few examples are like camcorders, cameras, etc. Next one is the household appliances. We know that we can say it as a smart home. So where we will be using in ACs, etc., etc., washing machines, digital cameras, micro ovens, etc., etc. Next one is a home automation and security system. As we are mentioning it as a security system, we will be using for intruder detection algorithms, where we will be using CCTVs also, etc. All the examples for home automation. And the next one is an automotive industry, where we will be using an anti-lock braking system, engine control, ignition systems, automatic navigation systems, etc. And the next application is regarding telecom. Telecom means where we will be using cellular telephones, switches, handsets, multimedia applications. And other examples like computer peripherals we will be using, computer network systems, healthcare where we will be using an ECG, EEG, etc. Next one is measurement and instrumentations. Also we will be using the same embedded systems in the different applications with the use of PLC system, digital CROs, logic analyzers, digital multiplexes. And in the service sector also we will be using the embedded systems like in banking and retail, where we will be using as an application of ATMs, currency counter, point of sales. And the last one is card readers, where we will be using in RFIDs like barcode, smart code readers and handheld devices, etc. Next come to a topic which is said to be a classification of embedded systems, where we will be classified based upon the generation, based upon the complexity and performance, based on deterministic and based on triggering. Okay. First we will see based on the deterministic behavior. So what is deterministic behavior? We have already discussed what is deterministic behavior. For the particular input we can expect a certain output, okay, certain desired output, which is said to be an deterministic behavior. Okay, it has been divided into two, hardware and software. Sorry, hard real-time systems and the soft real-time systems. Okay. Next here, and it is also said to be that deterministic system behavior is applicable for real time. So what is real time? Real time means here there will be no missing of deadlines. What is there is no missing of deadlines? Means we will be not missing any chance of the input not to be given as an output. Okay. Next one is that classification based on triggering. It has been divided into two, event triggered and the time triggered. Okay. Next classification is based on generation. So generation, as we are saying it as in generation, it has been classified into three generations: first generation, second generation and third generation. Okay, what is the first generation? So in the first generation, where we will be using a simple hardware circuits and the simple firmware in order to develop an embedded system. So for that purpose we need a microcontroller, where we will be using, either we can use a microcontroller or the microprocessor. So both will be combined to be said to be as a controller. Okay, here the controller is nothing but either the microcontroller or the microprocessor. So here in the first generation, as we are saying that we are using a simple hardware and the software in order to build a certain application here. So here we will be using an 8-bit microcontroller like 8085 and the Z80. Okay, and we will be using a 4-bit microcontroller. So 8-bit microprocessor and the 4-bit microcontroller has been used in the first generation. Next comes to a second generation. So second generation, where certain complexity has been increased. Okay, certain complexity has been increased in order to develop a certain application. Okay, where we will be using an 16-bit microprocessor and 8 or 16-bit microcontroller. Okay, so as we are saying that we are increasing the complexity in order to design a certain application. So where we will be introducing of instruction set in the case of second generation. Here are some of the examples like data acquisition systems, SCADA systems are the examples of second generation systems. And comes to third generation. So here is the third generation. Here much more complexity or the advancement of technology has been done. So in this third generation, where we will be using an DSPs. DSPs means digital signal processes has been used in order to develop a certain application. Okay. So here as we are saying that the complexity has been increased. So with this can be achieved with help of increasing the configurations of the microcontroller. Either it might be a processor or the controller. So here we will be using a 32-bit powerful processor and the 16-bit microcontroller for the design. Okay. So here as I said that we will be using an DSPs. Other than DSPs, we will be using an ASIC. What is an ASIC? Application Specific Integrated Circuit. Okay. And here also there will be an instruction set involved, which is of as we are saying, it has a much more complexity and advanced of the embedded system. So here the complexity has been increased with the introduction of instruction set as well as a pipelining. Okay, so here some of the examples are like we will be using in the fields of robotics, industrial process control, media, networking, etc. And the next one is then fourth generation. So in the first generation we will be using a simple hardware, in the second generation we will be using here the performance is considered as a criteria. So we will be using an 8-bit microprocessor and 4-bit microcontroller. In the third generation we will be using an DSPs, etc. etc. DSPs, application specific integrated circuit. While coming to a fourth generation we will be using a system on chips and reconfigurable processors and multi-core processors in order to get a high performance. For where we are mentioning it as a high performance, it will be considered to be a real-time systems. But whereas in the first generation, where we will be using a simple hardware and the software, where it cannot be used in the real-time applications. But where here the complexity has been increased. In the fourth generation, we will be using in the real-time performance. Okay, so we are saying it as a real-time performance. Real-time performance means it needs the system to be performed with greater speed, with high performance, and there will be a tight integration and miniaturization in the embedded device market. Miniaturization is nothing but reducing the complexity or the size or the design of the circuit is said to be a miniaturization. Okay. The fourth generation embedded systems are making use of high performance real-time embedded operating systems for their functioning. Some of the examples are like smartphone devices, mobile internet devices are the examples of fourth generation embedded systems. And next comes to a next classification which is based on complexity and performance. So based on complexity and performance, it has been divided into three: small scale, medium scale and the complex. Okay. So first one we will see what is a small scale. So small scale is same as in first generation. So where it is of an embedded system which needs a low performance, where we will be using a low degree of hardware design and the software. So here there are simple in application needs where the performance requirements are not time critical. What not time critical means? Here the missing of deadlines can be happen in the case of small scale embedded system. Okay, here the example is of electronic toy. Okay, next, and it is built around low performance, and we are using a microprocessor, the microcontroller, which is of 8-bit or 16-bit. And then comes to a medium scale embedded system. So medium scale. So we are saying that medium scale. So in earlier cases where we will be using, here in the earlier case small scale, where the performance is very low, where we might be using an operating system or not using the operating system. Okay, depending upon our applications. Coming to a medium scale embedded system where we will be using an operating system in order to develop a certain application. Okay, so there will be a slight complex in the hardware compared to a small scale embedded system where we will be using a low cost 16 or 32-bit microprocessor or the microcontroller, and we also use DSPs in order to develop a certain application. Okay, this is regarding the medium scale embedded system. And the next one is a large scale embedded system. So large scale embedded system, we are saying that the name itself saying it is a large scale embedded system and the complex system embedded system. We are saying it as a complex. Complex antenna where we will be using for high performance. High performance means in order to achieve a real time system. So this can be done with the help of, already we have learned that it can be achieved with the help of SoCs, system on chips, reconfigurable processors, etc. etc. Okay, so where we will be using, and sometimes we will be using an RTOS, real-time operating system, for task scheduling, prioritization and management. So in order to achieve a complex system, embedded systems, so where we will be using a high performance 32 or 64-bit RISC processors. So this is of today's class.